Hello, everyone. Greetings of the day. I hope you all are having a good day so far and a good week so far. So this is the second webinar. This is the second part of our webinar series, and we are going to discuss our design softwares, design methodologies, fun stuff. I would share my screen, do a software demo for our proprietary software that we use for our preliminary designs that we do. And also our customers use the same. Going to take you around the software, how to design a retaining wall, both the gravity and MSE with geogrid walls. So I hope that many of you are coming back after the first webinar. It would be great to see people returning to the webinar series. It's a compliment to myself. Okay, I'm going to start without any further ado. You may see that I would skip out of this presentation, take you to the software demo. So we'll be moving around my computer screen a lot today. Okay. So I'll jump right into it with the design methodology that we use. So for most of the projects, when I say most, these are the private projects, which are commercial, residential, or small county projects at times. We use NCMA design methodology. This also refers to, as many engineers know this as ASD method, the allowable stress design method. So AASHTO and NCMA. So ASD is one of the very beginners design methodology by AASHTO. From 1997 going up to 2002, they defined ASD as a design method for designing MSE walls. And then NCMA adopted this, and we still use the same method for our big block retaining walls. So what is the NCMA design methodology or the ASD method? It actually calculates the actual loads and then compares them against the allowed capacity. So it's more of like a demand and supply. So how much ever the wall loads are demanding is what we are supplying in the manner of reinforcement or extenders. So the theory that is used and by you will see that many softwares have a background coding. So that coding will be based on a Coulomb failure theory. The equations will refer to the theoretical geotechnical book with a Coulomb failure theory. The equations would be referred to that. And like I said, these are primarily used for design of commercial and residential projects. The next method that we can use is AASHTO LRFD design methodology. Now, as I said, that NCMA is also an older AASHTO method, which is ASD. AASHTO upgraded their design methodology somewhere around 2006, and in 2007 came out the LRFD, which is the load and resistance factor design. So here they say, like, the AASHTO derived at the conclusion that not all loads are acting completely or to the defined values. They may go up or down. And similar goes for the resistance provided by the wall mass. It can provide resistance not to the given exact value. So therefore, they introduced the factored loads and factored resistance. This gives us a very conservative um, design, because then you're assuming that the factored loads are slightly higher than what we're implying, and that the resistances are reduced. Therefore, our design is more uh, closer to the reality, to the practicality of the system. And this one uses the Rankine theory of geotechnical theoretical textbook. And these are primarily used. So AASHTO design methodology, we have many versions of it. I would show you that every 5 or 4 years, AASHTO upgrades their methodologies. I think we have 2010, 2015, 2020, and the latest one came out in 2024, towards the very end of 2024. And the last one is called stiffness method. The one before it is simplified method. And 2007, 2010 is limit equilibrium method. So there are different names for it and slight changes in how they use the factors, how the equations use those factors. But primarily, the purpose of the design methodology still remains the same, that it is a load and resistance factor design. And um, across US, all the highway and transportation projects, they uh, demand for AASHTO design methodology used for retaining wall designs. Um, so yeah, we will be going through um, the same method on our software. Like, I can show you how can you switch between them. So we have our own proprietary softwares. We have two of them by two different um, code companies, software companies. One is CTI Ware, uh, also known as Vespa. So they created a software individually for our block system, and it is available for all of our users for free and can be downloaded from our website. And then we have REA, which is Race Engineering Associates. Um, it is a design software. Um, Again, freely available on our website for all the users. And it depends on the engineer who want to use for designing our wall system. The I would say that the major difference, one critical major difference, is that REA can be used for designing gravity walls using AASHTO LRFT method. CTI, being an MSE wall software, can give you the gravity wall designs and geogrid wall designs uh, for the NCMA method, but can only generate AASHTO designs, design methodology for geogrids. So I'm going to repeat myself so that there's no confusion, and I'm going to keep it clear. CTI design software can be used for NCMA design methodology for gravity and MSE walls, and can also be used for AASHTO designs only for MSE walls, whereas REA can be used for AASHTO and NCMA for both gravity and MSE walls. The difference lies in their user interface. CTI is, I would call, more user-friendly, because someone who does not really know how to use a geotechnical design software can also use this. I would be giving a demo for CTI software today, as many of our attendees would prefer using an easier and um, uh, easy to understand, easy to use, quick to use. Quick is also one thing I find on CTI, that you can just simply input data and you get the result. REA is for heavy designers and heavy users who want who are used to using other geotechnical design softwares where you have to input most of the information based on your judgment and analysis of the project, and you can play around with those numbers. It's more manual than automated. So that's the difference between the two softwares. Now, where to find these softwares? So I tried best to explain on this single slide. I will give a demo as well. So you visit MagnumStone.com, you go to menu section, and then you select retaining wall design and analysis software. Scroll way down to the bottom of the page. Like, don't skip all of it. Like, go read the whole section, because you will get to know information about the software. There are tutorials for our software. And after all of those, you will find download for free buttons for both the software. You can click request download on either of those or both of them simultaneously. The software companies, they reach back with their license key to your email address. So you will have a request form when you click both the request download buttons. Both are separate, very different from each other. Not in the case of information required, but the page itself. So you will fill in the details, send it, you will get a license key number and a downloadable file. You will download the file on your computer, install the software, and that's where it will ask you for the license key. You enter that key and you're ready to use the software. You can always reach out to our team if you have concerns regarding using the software. If there is information that is confusing, or you want to design a project but you're finding a little difficulty, you can always reach back to us and we'll be more than happy to help you. Now, I'm going to escape out of this presentation mode and click open the MagnumStone.com website so that I can show you the demo of where you can find the software. And you click on retaining wall design and analysis software. So this is what I was talking about, that you can go through this whole page. It's full of information and all handy and useful information. So how to use the software, and getting tutorial videos. These show you how to start off using the software. But I'm hoping that this webinar would actually help you in that manner, and you will be able to use CTI design software much easily after this webinar. So you can click on request download. So you will get a registration. You fill it all up. Please accept the cookies, and you click on register. Email would be sent, and you will get the license key. Now, I am going to start with the CTI software. While I start this demo, I have a small request with all of the audiences here, that let's keep the questions to the end of this demo. I would like to answer as many questions as I can during this 1 hour time, or we can send you back responses on emails. But yeah, I would like to go through the demo first in a smooth fashion and then answer all of your questions, because I assume there would be. Okay, so you click open the Cornerstone Designer, and you'll not see this window. So I already had this open. So once you open it, it's a blank gray screen with Cornerstone logo in the center of it. But all of this is not there. It comes when you click on File and you say New Project. That's when you get this window. Now, this is the project information page. You enter the client name for for whom you're designing this, and then the let's say the project name is some shops, and it's a project that has retaining wall under a parking lot for a shopping complex that is upcoming in a location. I am in Mississauga, so I'm going to say Mississauga. Now you can enter a project number if you have something like that for your project management, and then this is prepared by, enter your initials, your name, whatever you want to, however you want this to be shown on project design report. So all of this shows up on your design report, and we'll get to it. Now, design methodology. This is the drop down that this is where you can switch between different design methodologies. To start with, I'm going to stick with NCMA, and then if time allows us, we will switch to AASHTO. Australia and British standards are also here because we are a global block company, and there are times when we have to design using either of them. So if you are also designing for either of these countries, you can select the design methods if your project calls for it. So sticking with NCMA, and then here is the measurement, whether it's an imperial unit you're following for the project or the SI. For the convenience of most of the audience here, I'm switching to imperial. Now, project notes, if you have typical situations on the projects, or if you like to keep some project notes for the engineer who are assessing your file, you can give some notes here for their convenience, because again, this would help them understand how you're working through this project. Now, project files. This is where you save your file. This is where all of the outcomes of this design software will go and save, be it a PDF, be it an AutoCAD, be it the design file itself. So you can go and set change. So for example, I go to my desktop, I go to this, and I create a folder that is a test demo, and I select this folder. So anything that I do on my demo right now will go and save on my desktop folder. You can always change it to whatever location suitable for your computer. Now, I'm going to talk about these tabs up here as we go on further designing this wall. So starting off, wall 1, you can right click on this, rename this wall however you want to. I can call it southeast wall because I'm imagining this is southeast wall. Okay, these are the empirical checks. These are the design values being used in the code. So these are design guidelines. You can read through them. This is the factor of safety that is being used for both static and seismic. Empirical checks that are in place, and design input only has one aspect, which is the reinforcement coverage ratio, which accounts for the geo designing. So it's for information only. Then you get into the wall unit. Here you have to select the type of block that you want to work with. So we have a product line under Cornerstone, and as you all know, MagnumStone is one block type that Cornerstone Wall Solution holds the license for. We have other blocks, so I'm only going to stick with MagnumStone today. So clicking on MagnumStone Gravity. Now, as soon as you select this product line, you have to understand, and I refer back to my previous webinar, that there are two ways you can use MagnumStone Gravity. You can use it with or without extenders. If you're using it with extenders, which is for most of the walls, we recommend designing with extenders because any wall above 6 feet is to be designed with extenders. So I select multi-depth set. Now clicking on this kicks in the extenders for the software. If you're not clicking on this, you will see that the wall units here are different. So these are only gravity wall facing units. So you have standard blocks, and you have standard blocks with caps, and then you have half-height blocks. But if you select the multi-depth set, you will see that now the MagnumStone with extenders kick in, and then MagnumStone with cap. Now, the difference between these two is that one of this, so when you click MagnumStone with cap, it shows cap units for the length of your wall. You will still get extenders, but you will get caps too. But when you're clicking on MagnumStone with extenders, you're only going to see extenders and top block unit. There will be no cap unit. So for projects that are specifically asking for capping units on top blocks, you click with MagnumStone with cap. Now, everything here, again, is for information only. You cannot alter any of this while using the design software. Reinforcement is something we will come back to when we're designing with GeoGrid. This is very important. This is the game changer. Soil conditions. Now, when we say reinforced, and in the case of our wall system, there are 3 zones for the retaining walls. There's reinforced, there's retained, and foundation. Typically, retained and foundation are the native soil of the project site. Reinforced is the backfill coming into the wall system and the wall mass. This is the soil that is going to resist the loads sitting on top of the wall and work along with either the extenders or the geogrids to create that resistance against the loads. So having an assumption that this is a well-graded soil with friction angle 37 and a unit weight 140 is most common. It can change depending on the clean crush gravel aggregate properties for your project. This and I've worked through different projects, and I know that when you're between 35 to 38 degrees, 130 to 150, you get pretty much the similar results. It does not vary your design as much. Now, the second is retained and foundation. This information is available on your geotechnical reports. You have to go through the geotechnical reports and see the subsurface soil and the boring data that they have on those reports to understand how the native soil is. You can either select the unified soil classification mentioned in the drop-downs here if you have the geotech report that clearly mentioned that. If not, then you can either select it based on your understanding of that geotechnical report. Suppose your report says that the soil is clay with a mix of silt and sand. You can say that it's an inorganic soil, inorganic clay with medium plasticity, gravelly, sandy, silty. Or you can, if you come across a sandy soil, then you select the unified classification for sand. So I'm going to stick with clay gravels, poorly graded. So they give you a friction angle of 32. So this is automatic. It changes with the selection of the dropdown. Now, if you don't know what to select on the drop-down, but you do have an idea of the friction angle and the unit weight, you can go ahead and change it manually. You don't have to go and select this. So suppose I say that my soil only has it only has a 30-degree friction angle and has a unit weight of 125. I'm going to stick with that. So I'm manually changing this. Sometimes it goes down to 115, depends on the soil type and your geotic report. Now, leveling pad is well-graded gravels compacted to 95 or 98% standard proctor, depending upon the location and your project specification by geotech. So you can either select this, or if you have a concrete base, you can change this to like 40 degrees if you want to assume the friction angle for concrete at 40 degrees. Drainage is for gravity. This software automatically assumes that there is a minimum of 12-inch drainage behind the face of the wall. For reinforced, you can enforce the face drain, the blanket drain, or the chimney drain, depending upon your project. Since we are working on gravity, we would not select any of these because it would not come in effect. Now, after you're done with the soil, this is another important, very important aspect, especially if you are on the west coast of the North American continent, because that is highly seismic zone. Also, I believe it's the southeast part of US that has seismic region. And across the world, there are many places that we come across have seismic indexes high enough to be included into retaining wall designs. And if a wall design does not pass for seismic analysis, it isn't safe. So we have to include seismic analysis if we are working for some place like that. So you click on include seismic analysis, and then you go and find what is the peak ground acceleration for that particular location. And once you find that peak ground acceleration, you can enter it here. I'm going to keep it checked out for now because we are simply going through a demo, don't want to make it complicated. Now, after extreme events, you come to stations. This is the geometry of your wall system. This is where you are going to enter the elevations of your wall. So let's say that I'm going to assume something's here. So I'm going 2 feet to start with, and then I keep on adding. Let's say that I'm going 30 feet forward, and then I reach. I'm going to keep the ground level for this demo. You can always have a very simple or a complicated elevation of the wall system depending on your project, right? But because we have a shortage of time here, right? We are already half the time out. So working fast through this, I am going to enter values. Okay, I'm assuming that my wall only goes high on one side. This is good to show you the different profile, the design, and how to put load conditions on it. This is where I'm going to just assume that my wall ends at being 15 feet high. Yes. And now, while I'm here, I'm going to finish the toe geometry and the slope. So now if you have a toe slope at the base of your wall, you will select toe geometry. This gives you the importance. It's a note that indicates how toe geometry is being included in this design. So you can calculate the toe offset from your base of the wall, and then what is the toe elevation. Of course, the toe elevation is going to be lower than your bottom of the wall because it's going to be further down. So you can enter your toe offset, whether it is like a 1 feet or 2 feet or maybe 5 feet away from the face of your wall, and then put in the toe elevation. How far down does it go, the toe? And if you're not checking this, it would not show up, right? And then you have uh, simple crest, simple wall elevations here. You can add and delete these stations based on this. Now, suppose you don't know, and it's a very long wall. This suppose is for very long wall. You have a wall going up to like 800 meters. All of the survey points may not be given. You have some top of the elevations, you have some bottom of the elevations. If you have like 50 top of the walls and 50 bottom of the walls, but then you have certain values missing from them. Let's say top elevation values have 6 of them missing, bottom elevation has like 8 of them missing, but you have somewhere around 40 points for top and 40 points for bottom elevation, and you enter that 800 feet long wall into this chain age. Those missing points can be added by clicking validate. The moment you click validate, it will so the software will extrapolate those points and those elevations based on the input made here, right? So that comes in handy when you have certain pieces of information missing, but you still want to design the wall to the most accurate points. This button here, import, you click on this and it gives you a caution that your values can be empty. So this is how you're going to create a data outside of the software. So you go to Excel sheet, you take 3 columns and you enter the station, the top and the bottom, right? And then you save it as a CSV file, the comma delimited file, and you save it in the same folder where you are saving all of this. For me, it would have been the test demo folder. And then you click import, you click yes, and then you go to that particular file. See, it automatically takes me to that test demo folder. Now, if I had an Excel sheet in a CSV format here, it would show up. I click on it, I open it, and it fills in this side. So you don't have to manually enter it. Oh, well, you technically do have to manually enter it, but on an Excel sheet, not on the software. It's easier when you're working with larger walls because any change to be made here alters the whole elevation. So you can make changes on the Excel sheet and bring in the import. Going to the panels, this is where you see how your wall panelization would appear. So I've entered it's at 15 feet to be the highest wall section. Now, this is the bottom of our wall, but with embedment, it goes further down. Now, embedment, very critical, very important, especially that we are a big block. Our block size is 2 feet high. We embed 10% of the total design height as a minimum, Now, it can be either 10% of the total design height or half a foot, depending upon whichever is higher. So the higher value will automatically be assumed on this, and the software will keep on adjusting the embedment for the wall system depending on the height. You can change the embedment to whatever percentage you like. If you want to embed like 20% of it, you can change it. Or if you want the minimum to be a foot or a 2 foot, then you say a minimum of 2 foot here, right? All this information will alter your panel. Clicking on grade to top of the wall. This is something that will make your grade in the design section go all the way to the top of this wall. So I would click on this so that we have the block at the same level, the grade as the same level as the top of the block, because our blocks are protruding outside the grade given. for covering the certain height differences. You can align your grades to the top or to the bottom. It changes your view for the wall panel. So here, since I had 0 feet as my ground level, I've leveled the wall and it's changed the panel. This looks more uniform to the station and the elevations that I entered, right? So you can play around with this, not exactly play around at your own will, but to optimize the wall area to your project wall surface area. Here are the markers. How are they to be used? They are to indicate a corner, a curve, a utility. Any special feature on your wall can be mentioned here. So for example, I say that for my wall at station 50, I have a corner. And this is an inside corner. So my wall will turn 90 degrees into the paper, I would say, and I select corner section. Now, what does this do? Including this will add the corner sections into our block count summary. Yeah, so I hit save and then I close this. So you see a marker at 50 feet at my wall here. This is where my wall is turning. Okay, now loading conditions. Very important again, very versatile depending on your project. Um, Certain values that are off, that are easy to assume and are practical. If you're using this project wall, let's say for landscaping purposes, but there is not going to be a vehicle on top, it's just some plantation, some landscape. 60 PSF is good. Uh, if you have a walking trail on top, 100 PSF. If you have uh, a driveway, but only for small vehicles, no trucks, no construction, no fire trucks, no highway trucks, 150. And if you're doing the live load for vehicles, trucks, bigger vehicles, the load soldier changes to 250. And the live offset, so I'm going to assume 150 live offset. How far is the load from your wall face? So it has to be a minimum of 4 feet. You cannot simply put load directly here. Try and avoid it unless your project says otherwise. It does impact the design a little bit, not much, but a little bit. Also depends on the live load, like what kind of live load you have. For landscape, for example, you have a landscape on this wall, probably the offset is going to be 0 because you have grass coming all the way here, you have some plantation on top. So it depends on the project. Dead loads. Dead loads are very important to be added because they are game changers for design. If you have a building right behind this wall, there's a dead load. And depending on how far off this wall is from that building, you have the offset limit. Dead load, typically for a building, counts somewhere between 500 to 600 PSF. So yes, that is why I said it's a game changer. You put that much off dead load, the design would change drastically. For landscapes, for slopes, now that is another way of putting dead load. If there was a slope sitting on top of this wall, I'm going to assume that there is a 10-degree slope on this wall, right? And I say that the slope is 1 feet away from the face, right? This slope, the soil mass here, is going to cause dead load. It's sitting right there, right? It adds. So I'm going to add a 60 PSF of dead load sitting right towards the face. So this is a dead load here caused because of this soil. Right? And I'm going to assume that this is only for The slope is only for these last 3 panels after the corner. So I apply this to, actually, I'm going to copy this from left. Oh no, it's my right. Sorry, I have 2 rights. Then again, I'm going to copy from right. And for this one, entering this, and I'm going to extend to my right. Okay, sorry for the little error here. This is the fun of doing a live demo. You know all the mistakes that you can make when you are designing, because I'm making the same mistakes. Sorry about that. Okay. Every panel has its own information in this small box. What is the maximum design height? What is the exposed? What is embedded? And what is the design height? The stations left and right are given. So you can always check for different panels, how far off are they on your stationing, and what's the design height you're working with. Then you go to design and you say generate all. This is the automated version. So you just select generate all. Coding kicks in. The software gives you an output, right? So you see that it has connected long extender to a short extender at the back because it wanted an 8 feet. And in this case, we have a 6 feet because so all these depths are actually from the face of the wall. This is confusing at times for the users that is this a 6-foot long extender? No, it's not. It's the total length from the face to the back of the extender that is shown here in your design. Yeah. Now, if I had introduced this size extreme events in the seismic, so I included seismic analysis, my design would again show values here for this section, whether or not it is passing in the seismic analysis. For now, we only have a static. Now, if you're working for walls higher than 20 feet, and I've observed that if I work with walls higher than 30 feet, I have to go in and manually input the extenders. Please keep this in mind that this generate all will go, will give you accurate results till well up to 21 feet. But after that, if your design section is failing, it's not because it is failing and the wall isn't working. It's because you have less extenders and you have to go in and manually design this. So for doing that, you select this section, it becomes purple. You go to right click on it. And when you do right click, you can select change to longer depth and change to shorter depth. Now, please remember that theoretically, the total design height ratio to the depth of the extenders is 50%. So if you're looking at your design section and if you see that it is not between 45-50% and the wall section is failing, you have to increase the depth of this. So please go in, select it, do right click, go to longer depths and increase the depth of the extender for each level as you see here. Now, how will you know which panel is working and which panel is failing? If a section fails, you see at the course number. Now, what is a course number? The number of blocks from the bottom of the wall. So this is course 1, 2, 3, 4, 5, 6, 7, 8. This is 8 course high. So this thing is showing the maximum value of this whole section, right? So at course number 4, the overturning is 1.59. That is the maximum, sorry, that is the minimum that is in this section that is available for these courses. So if I go to 1, 2, 3, 4, this is where the overturning is at its minimum. That is 1.5, which is closest to the factor of safety required for a wall to work, right? So yeah, when you're extending these manually, you will keep on seeing the result changing for each and every course. So as you look at the course number changing and the value, the more closer you are to 1.5, the more probability you have of your design succeeding. Yeah, small tricks, but very important when you're designing greater height boards. Yeah, this is where I'm going to stop for this. Now I go to the GeoGrid. I'll quickly flip to the GeoGrid. How to change? I go to wall unit. I select MagnumStone GeoGrid, deselect the multi-depth set. That's how you get the standard blocks for MagnumStone GeoGrid. So you select friction, standard friction blocks, and you go to reinforcement, whatever reinforcement you want to work with. If you have a specific on your project, please select. If not, whichever works or whichever you like to work with the most, depending upon the availability and the supplier in your region or the project location. So, sorry, I kept clicking while I was talking. You select the GeoGrid. You can either double click or you select the GeoGrid and you click this green arrow. So these are used in this wall. I'm going to click all of them. Now, all of these GeoGrids, if needed, I have 4 different categories of GeoGrids that can kick into the design as in how required. Again, information here is for your knowledge only. You cannot alter this. It's in the coding of the software. Here, if you want to change the soil category, you can, because that alters the way GeoGrid reacts with the soil condition. Keeping the soil condition same, I'm going to keep the station same since we have it already. I don't suppose I should change any of this. Panels is what I would change because I simply have to click generate. The software has to know that I'm using a new wall unit, and just to make sure that it accounts for that wall unit change, I hit generate and everything remains the same. So loading conditions, loading the wall again. This time I'm going to keep it simple, apply it to all. So you have the loading condition on top of all of them. Now you come to design and you can click generate all. So the coding brings in the GeoGrid required. I'm going to minimize this so that you can see what GeoGrid type is being used. Yeah. I believe for the loading condition and the height of the wall, we have similar grade of GeoGrid being used across the length of the wall. Now, one thing you may see is that the length of the GeoGrid is different for different level and different courses. In my experience, having this condition, it's irritating for contractors working with this design, because then they have to be so much more cautious, because if they don't stick with this, it's going to change the design altogether. Please check force uniform grid length. What will happen is that this change of GeoGrid will not appear. Now I click generate all, and I have the maximum length of GeoGrid. This is also very handy when you're doing a preliminary design check, because it keeps you conservative, right? That's my personal opinion. Like, you go for the maximum length of the GeoGrid, you make the prelim conservative, and if the engineer comes in and says, oh no, the slope is much steeper, you at least have some room to save. And this is from all of the preliminary designing experience. I'm saying the final designers, they may not opt for this because they're optimizing the project design. Okay, so yeah, this is all that I have for design side on how to design using the software. Other things that you can do is you can copy this wall. If you have different stations but want to keep the same loading conditions and same soil data, you, not the loading conditions, I'm sorry. If you want to keep the same soil data, same wall unit type, you say copy wall and you can name the wall. But if you want to keep suppose it's a mirror on the other side, or you want to test this wall for a different loading conditions, you can copy this wall with stations, not have to enter it again and again. So this is how this is user friendly. This is why I say this is software that is quick in giving you outputs. Settings, uh, referring to this for single thing, it is the packages. Sometimes, as every other software does, our software also brings in updates and upgrades. Um, I recommend any user to update their packages once a month, I would say. Not that we do it so frequently, but it's always safer to just go in and click on packages, select the standard, refresh them all. It would take some time, and then you save it, and you will have all the packages updated to the latest version of the software. Mm, taking a little while. Okay, save, close. I know my software is up to date. Now, clicking on File, the real reason why we are using this software is to get a PDF report or exporting it to AutoCAD. So I'll do the PDF report first. Um, you can select all the sections if you want. If there are multiple walls, you can select all the walls, or you only want to report for one particular wall, you can select that one wall. So you can make the selections by clicking Control and selecting all the sections that you want. But if you want for all, you can select all. And then how detailed do you want this report to be? You can select all that you want on your report. So if you are only doing a project material summary, you can click here. It'll give you a block count summary, geogrid amount, back the backfill amount, the core fill amount. It gives you every information regarding the quantity estimation. But then if you want the section analysis for your wall sections, then you click on wall section analysis summary. For any preliminary package that you may receive from us, you would see these selected. Like we provide all of this because um, our analysis goes to different engineers and they want to look at the analysis we have done. You can also select project design inputs so that the engineer knows what all has been used by you for the design. And then, of course, if it is to be more detailed, you give in static and seismic calculations. And if you, whether or not you want to just include a prelim, now you can design both final and prelim design on the software. So if it is not a prelim, just not check it. Now, as I said at the beginning of the demo, the PDF reports, any file that you export from this will automatically go to your saving location, right? So I hit save, it goes and gets saved there. I can hit preview before saving if I want to look at what information is going to be here. So yeah, this is how it appears. So the first page is block count summary. Like I said, it's only for quantity estimation purposes. Then comes the section analysis summary. It gives you all the values calculated by the code. So yeah, this is what we give out on our preliminary packages if you've come across one. Closing this here, taking to the AutoCAD part now. The part of our prelim package that you see, you also find drawings attached there. This is how we do it. We export to AutoCAD. You can select the wall. If there are multiple walls, you will select one each. At time, you can only do export for one wall. You can include whatever view you expect. So if you don't want a plan view, I would deselect it. Section and elevation, a big yes. Now I want to select because I'm selecting the section view, I'm going to select all the sections by holding shift, clicking first and last. It selects all of them. The files will automatically save into the folder here. I click export, and because I have this open saved file, my AutoCAD will open up and show me the file as it gets transferred from the software. We are almost towards the end of our demo and also the timing of this presentation. After this, I am open to take on questions. So these are the sections. So this is how, so it took every panel section from our wall design and gave me the a wall section here. Now, for my package, I could either use the maximum height to give the engineer an idea of what is the maximum geogrid length that I'm using, what kind of geogrid am I using, and then I have elevation view. So this is the elevation of our wall, and you can make edits as per your template if you have one. Uh, we do when we take this and we paste it into our template and make edits accordingly. So yeah, this is how you get AutoCAD export from the CTI software. All right, this I believe is the end of our demo for now. I'm going to go back into the presentation here. So to closing this, the next webinar, hope to see you guys again in the next webinar, which is on March 26th. We will be talking about hybrid walls, how to select geogrid gravity or hybrid retaining wall solution for your project, and advanced applications like water applications and erosion control and highway projects. I will take you through some case studies of projects that have been done. And an overview of our support system and our services. Um, yeah, thank you. Thank you all for attending today's webinar. I hope you enjoyed the demo. I tried going through all of it. I know it was quite fast. You can always revisit this, I know, because Dave is going to send out a link of this recording to every viewer present today. You can follow us on our social media pages. We are on Instagram, LinkedIn. We have YouTube channel, Facebook page, and a Pinterest page. Marketing team does a really good job. Simply going to our website can give you loads of information about our system, installation guidelines, designing this design softwares, case studies, project profiles, and many much more. So please follow us everywhere you can. So do we have questions? Okay, I'm going to just close by saying you can always reach out to any one of us on our team. You can send your emails with query to either myself or send a request from our website. It reaches to Dave with engineering questions and he sends them my way and we reach out with answers. So yeah, all questions are more than welcome. I hope you enjoy using the software as much as I do, and happy designing. Thank you, everyone. See you on 26th of March for the next webinar. Oh, I have questions. Revit, I don't know. I can ask CTI about it, but not as of now. REA software, I can do a one-on-one. We don't have a webinar series specifically for that, but if you want to get a demo or a session of it, we can do a team session. You can always send us a request and we can go through it. Okay, with this, thanks, Mason. Thank you, everyone. See you in the next webinar. Bye. Have a nice day.